Hello everyone, welcome to my Calc 3 videos. Today we're going to talk about limits and continuity. So let's start with a true or false question. It is much easier to prove a limit exists than a limit exists, right? So this is a subjective question, but from my experiences, from helping students over the years, what I realize is it is so much easier to prove a limit does not exist than to prove a limit exists. Well, I'll explain that why, okay? So again, the true or false question. If a limit of a function along the x-axis, the y-axis, and along all lines of y equals to mx, and n can be any integer or not even any values, any real numbers. If all of these equal to 100 at the origin, then the limit of the function must be 100 at the origin. Right? True or false? So this is actually a false statement. Why is that? Well, you say, oh, well, I have already approached from the x-axis, the y-axis, and all of these straight lines across the domain. Well, what about, let's say a parabola, right? I'm approaching the origin from a parabola. What about, a cubic function, right? Right. So you have to do so much work to prove a function exists, then to prove a function does not exist. But that's not to say there are no way to prove a function does exist. So here's some of the tricks that we can use to prove a function exists. Okay, so the first thing I would like to show you is something called for trigonometric functions, right? So for trig functions, right? So we can use the u sub and we can use the combination of u sub. It's not the same u sub as we have you and me have known before, so that's why I put a quotation mark up there. And we can also, and the second tool that we're going to use is called the hospital rule, right? So that's for trig functions. I will explain how we are going to use these tools together in an example problem. And another case will be a power fraction rule. So the shape of the function will look something that has a power, that has something that's on the power of 2, power of 4, and then it also has some fractions, right? It's made of some fractions. So I'll call them power fraction case. This, we're going to use some concept that you might have learned in pre-calc that's called conjugate. Right? So I mentioned these two types of functions, but you don't. There are some other functions that you can find limits that does not use these two, but these are the two ways that you will be required to understand and master. And then these two are the ones that show up most frequently. And let's talk about continuity for a brief moment. So, in general, how can you test the continuity at the point for piecewise multivariable function, right? Well, the way that we can solve this subproblem is, first of all, we can have we can just go ahead and substitute, right? So we can evaluate, right? You evaluate the function at that particular point, right? A and B, right? So I'm going to say value at A and B. And the limit of the function, right? Limit of f A and B, right? As we approach to the point A and B. So if these two if these two values match, then the continuity exists, right? If these two values does not match, then this function is not continuous at point AB. So let's go ahead and solve some exam problems, shall we? So let me go ahead and open these documents and then lay them over. So the first question that we're going to look at is evaluate the function at the location of 0, 0, right? So one giveaway is, one thing that the question asks you to do is to evaluate, right? Is to evaluate this function. And the second giveaway is we have this big limit notation, right? So this is obviously a limit evaluation problem, right? And the keywords are to evaluate and then the limit notation. So the first step is, I would say it's always to plug in the point first, right? The point that they want you to evaluate the limit at, and check to see if the limit actually exists, right? If it exists, you don't have to follow the rest of the process, right? Your problem is already solved. But if you run into 0 over 0 or infinity over infinity, right, that's a problem for us. So the first step is we're going to take is plug in the 0 over 0. So limit x, y approaching 0, 0. The function is f of x, y. Right, this, I'm going to skip all of the process. You will realize the fraction give us 0 over 0, and then the exponential will give us 1, right? So the key is right here, right? This is a problem for us. So this limit is, this evaluation approach is not limit, it's not valid. So because it's not valid, what we're going to do is we're going to try to simplify the expression if we can. So for the power fraction case, as we have discussed, we can find and multiply the conjugate, right, to simplify the denominator. And then for the trigonometric case, we can reduce the number of variables via the so-called U substitution, and then use the L'Hopital rule, or the hospital rule, how we call it. I don't know. So in this case, right, if we take a closer look of the function itself, right, we have a fraction and we have a bunch of powers right here. So it's easy to say that this is, I think it's, we can conclude that this is a power fraction case, right? Then we can simplify it by finding the conjugate, right? So the conjugate of this function, right? In this case, we're just going to find it because our numerator has more power than the denominator. So we can break that down. We have y fourth minus x fourth, so that's going to be y squared plus x squared, y squared minus x squared over x squared plus y squared, right? So these two terms will cancel, and then we have e to the x squared plus y squared, right? This is what we have end up with after the simplification. Right? So we have simplified the functions successfully. After that, we're just going to plug in a point and find the limit, right? So step 3, right? So the limit of x or y approaching to 0. I'm going to duplicate this really quickly so that I don't make any mistakes. This will equal to 0 times e, 0 plus 0. This equals to 0 times 1 equals to 0. So this approach is valid because it has no 0 over 0 and infinity over infinity that's showing up in our limit evaluation. So therefore, the answer to this question is A, 0. So this is pretty quick, easy enough, right? Because the idea is that whenever we have a problem of 0 over 0 and infinity over infinity, we're going to try to simplify the expression of the function. So I just showed you a power fraction case. Well, what about a trigonometric case, right? So let's try that. Let me go ahead and grab this exam really quickly. Exam, so this is fall 2019. And then let me go ahead and cut it, and then we're going to make some space right here. Okay. So let's read this question again, a new question. So assuming that this function, the limit of this function exists, then what is its value? Right. So first glance, that this is a limit question, right? Because we have this limit notation, and we can see the expression of the function has the trigonometric function in it. So this is a trigonometric case. So we're going to just follow the same process, right? So the first step is going to be evaluate the function at 0 over 0, right? So I'm going to go ahead and copy this notation. It's kind of pain to write it down, so I'm just going to copy and paste, save me some time. Is sine of 0 over 0, so that's 0 over 0, right? So that's a problem, right? And then step two, right? We're going to realize that this is a trigonometric case. I'll call it a trig case. Then, right? So the u substitution is, right? We're going to let u equal to sort of the common term in this problem. The common term in this problem is, well, if you notice that this part is exactly 4 times as the bottom one. So we're going to let the bottom one be our expression of a u. So that's x squared plus 2y squared. So then the function can become sine of 4u and the sine of u over u, right? So why can we do this, right? The idea is that we define a variable u that's encapsulate all combination of x and y, right? So it doesn't matter what the combination of y anymore, right? It doesn't matter if it's x equals 0, y equals to 0, or y equals to mx or something like that. And also cubic, right? Square, parabolic approach, right? It's all encapsulated in this variable u. So the third step is evaluate. So evaluate, we're going to utilize the help of the L'Hopital rule. So that will give us limit of u approaching 0 with f equals to, well, in L'Hopital, right, we're going to take the derivative of denominator and numerator. So cosine 4u times 4 and then 1, right? So that just gives us 4 times 1 over 1. That's just 4. So the answer of this question is 4, echo. So this is the idea of how to find limits using these nifty shortcuts, right? Again, I want to remind you that you should plug in the point first and check to see if the limit exists, right? Even though sometimes you don't see this power fraction case, trigonometric case, don't give up, right? That's why I have the first step available for you so that you can plug it in just to see how it turns out. And that is pretty much all I have to say about limits and continuity. I thank you very much for watching. I hope you learned something. I hope you can understand and master the one-pager, right, the solving process rather than the numbers that I've shown you. And I will see you in the next video.